Hey everyone, I'm Michael, and welcome to another Thundershock Engine devlog slash update on um, the whole sort of deal with with all of my projects right now. So, I'm gonna start with the announcements first. The first announcement is that my internet service provider kind of hit itself today, and the issue's resolved. I tweeted about it earlier and I retweeted their whole tweet, but it's all resolved. We're back to our normal speed. So I should be able to do a live stream this weekend. I don't know if it's going to be tomorrow, it might be Sunday, but I can do a live stream. And that's good. The reason it might not be tomorrow is because I've got a lot to do as far as setting up for that stream that I would have done today if the internet was working well. But obviously with very poor internet, that's not exactly possible. It might be a Little Big Planet stream. I'm not sure. It might be a programming stream. It depends on what you guys would like to see. If you have any suggestions or any ideas for what I should stream, but I'm gonna be doing a stream this weekend. I'm just not sure what it's gonna be about. As far as Thundershock goes, things are going really well. Um, we've done a lot of work this past week to get it all good to go and running, and Red Team running in it, and I'm really happy to show you guys that now. I'm going to be doing these devlogs really frequently to show you guys the progress of all this and how it's going. And hopefully, sometime early July, there's going to be a tech demo release of Red Team showing off the new engine. There won't be much in the way of gameplay, because Red Team is still very early in planning process, but you will be able to actually play around with a debug build of the game and the engine and see how things go for you. And the reason I wanted to do that, great timing phone, I really wanted to know that I got an email from GitHub. Um, the reason I want to do that is because I want to know how the engine runs on your systems. I want to know if there are any issues with crashes or performance or anything like that, and any sort of bugs that would happen, because of course this is my own game engine. It is my own code through and through. There's bound to be issues, and I don't want to release a full game in an engine that barely works outside of my system. So I'd like to figure out how I'd like to test the waters with a little tech demo. So that's the plan. That's what we're working toward right now. Um, but until then, I have quite a lot that I can show you from this week as far as development goes, and so we're gonna get into it. All right, so we are in Red Team. I'm going to be redoing the intro over the weekend, probably. Actually, if you guys would like, that would be the stream that I do if we decide to do programming, is writing this intro. Which might be fun, because it's very visual. I have an idea for an intro I want to make for the game. So, we might work on that, but for now, this is basically the same. But, Dev Console. It's fully working now. I did a video of this the other night showing you guys how I was going about implementing it. It's fully working. Everything's fully working in it. It's amazing. I love this dev console implementation. As you can see, or as you heard, I hit the tilde key and it popped up straight away and it gave me a bunch of information about what's going on with the engine at this point. Now there are some issues going on. There should not be this much stuff spamming the console when you open it. I might have a fix for that. So that's a potential thing that I'm gonna have to rethink in Thundershock, is fixing these issues with the OpenGL stuff. It's trying to recompile a shader. It really shouldn't be recompiling that shader. This shader that it's complaining about is the basic engine shader that, makes all of this work, and it should really be reusing that shader program. So I've got to fix that. But the dev console itself works really well, and basically the way it works is you can type sheetmanager.help. I will be adding aliases eventually, don't worry. But you type sheetmanager.help, it's case sensitive right now, another reason I want to add aliases. And it lists all of the different commands you can do in the engine right now. And there's quite a lot already. There's a lot of post-processor stuff, and that's what I'm going to show you in this video. Also, I fixed a bug where where typing in your console command, if you hit enter, it propagates to the scene. I don't know what was... I didn't really fix the bug per se. I worked around it, but you know, that works for the time being. You no longer trigger scene events when you're typing in console commands, so that's good. Um, but as far as actual console commands go, we have our noclip command, scene.noclip. Scene is literally for the current scene, so it's contextual. So I can do scene.noclip, and it's going to tell me that the command is not... Did that not work? Oh, I know what happened. You have to give it a Boolean value. It's no longer like it was before where you could just type in noclip and it'll toggle. Now you have to give it a true or a false. So true turns it on and false turns it off. There we go. And then of course you have your, I believe, scene.setCamMode perspective. And that'll get you into our perspective view. And then you have to close the console because input actually works now, and I don't see anything. Well, that's not good. I will have to look into that. But this would have worked. This would have definitely worked if not for a bug that I'm not sure about, so... Let's have it reset itself. Okay. So, I don't know what... I think... I don't know what happened there. Let's go into the main menu. I was gonna show you guys what that was looking like, but it seems like there was a bug. I'll have to look into that. That would have worked. I must have changed something in the engine to break it. I don't know. But, anyway. Shaders. Post-processor. You guys are really excited to see that, I know. I know you guys are. I know that you guys want to see the bloom and the CRD shadowmask, and it's all working. Thanks to wonderful help from silk.net and the graphics programming Discord server and the monogame server, I was able to fully port the bloom shader and the CRT shadowmask shaders from original Thundershock into OpenGL Thundershock, so it all works perfectly now. Now, as far as settings go, you can't turn them off right now. That's a bug. I haven't exactly figured out how to implement that just yet. I'm working on that. There's going to be some missing features as I port these things over, but the shaders themselves work. Resolution select is now working again in Red Team. So you can select your different resolutions now. Now, you can't scroll for some reason, which is annoying. I'm working on that. I have to figure that out. And the GUI does not actually properly scale anymore. I have to fix that. But you can actually set your resolution now, and it does work. There is, however, a bug with these buttons here that I ran into doing some optimizations, and the text is not centered. So that's not great. I'll have to fix that. But the About screen, it works perfectly. All of this works. Pretty much, this is the exact same build of Red Team through and through that we had in Monogame, except it's missing textures. So, that's amazing. If it weren't for the textures being missing, you'd probably get this confused with a Monogame build, because it looks identical. Anyway, we're going to boot my last OS, which is probably going to be Richie from Pokemon, to be quite honest with you. And we'll get into the game and show you what's going on in there. Oh, it seems that the fixed time stepping has fixed itself. That's great. Alright, so we are in a console. Okay, so Neofetch. Always gotta start these videos off with Neofetch. It works perfectly. In fact, it works better. See, on my KVM system, it actually would say that, yeah, I have an AMD EPYC Rome processor, and that's not true. I have Ryzen 7 3700X, but this is the emulated processor that KVM tells Windows I have. Um, in monogame, it would actually freak out and have a bunch of question marks, like, AMD EPYC Rome processor? You have that processor? No, what? It was questioning me. Now it's not. That bug has been fixed. I don't know what it is with the text rendering in Thundershock, but it no longer has that issue anymore. So that's good. Um, but other than that, NeoFetch is the exact same. The way you tell the difference between a Thundershock OpenGL build of Red Team and a monogame build is you look at the kernel string. If the kernel string says Thundershock 1.0.0.0 or whatever version of Thundershock you're running, then you are running an OpenGL build. If it says Microsoft.xna.framework or monogame.framework, you are running an old build and you should update. So yeah, that's NeoFetch. The only difference is A, it's not questioning what your processor model is anymore, and B, it tells you what your Thundershock version is rather than your monogame version. That's the main difference. Oh, and I forgot to mention that the graphics card display tells you your graphics card vendor and your model ID. So it says NVIDIA Corporation, NVIDIA GeForce RTX 2060. It really wants me to know that this graphics card is made by NVIDIA Corporation. Even though really this is an Asus ROG graphics card, if I remember correctly. But, oh well. I'm just displaying what OpenGL tells me. But yeah, the frame rate is a little bit inconsistent as to what it's actually supposed to be. That's because commands are not asynchronous in these builds, and they won't be. They don't really need to be. I can work around that, but anyway. Let's actually mess around with the post processor now. Now, what I'm going to do is I'm going to type in colors, and that's going to give me some more demo text for this console. This is pretty much the same as it was in monogame. And what I'm going to do is I'm going to pop into my dev console here, and we have a bunch of commands from earlier. We have all of the commands that are under the post processor. So if I do shape-manager.help, it's going to give me a list of those commands. So we've got a whole bunch of stuff. Mostly it's just Bloom. So postprocessor.bloom lets you turn Bloom on and off. So we can demo that. Pay attention to the background. It does not affect the dev console. So postprocessor.bloom false, and that should stop the colors in the background from glowing. And as you can see, they do. Something went really strange with the CRT shadowmask effect. I don't know what happened there. That does not look normal at all. Yeah, that's definitely broken. I'm gonna take a screenshot of that. So yeah, that broke. I don't know. Oh, actually, I know what happened there. What happened there is there's a bug in rather, there's a missing feature in the Thundershock engine right now, whereby it won't actually render the proper effect buffer, or proper... It's hard to explain. I'd have to show the code to show you what's going on here, but this is a bug. This is very much not what that shader is supposed to do when Bloom is turned off. This is a bug. But we can turn that off. We can turn off the CRT shadow mask shader. What we do to do that is we do, I believe, post processor.crt false. And it ignores us because that's not actually a valid command right now. Let me look. Post processor.bloom, bloom, 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 bloom. Yep, CRT. Okay, so yeah. It flat out ignored me. Okay. Let's turn bloom back on. There, everything's normal. And I do actually think that the shadow mask is now turned off. So, yeah, pretty convincing shadow mask effect there, except it broke. Let's do post-processor, just to make sure that it is on. Alright, so it's turned on again. I'll have to fix that, but let's actually play around with the bloom effect and see what we can do as far as the colors go. So, the first thing that we can do is we can blur things with the bloom blur command. So, post-processor bloom blur. I believe by default it is 1.3. If I take it up to 1.6, you're going to see a little bit more glowiness. A little bit. But not much. Not really that much. So let's take it up. Let's make us look like we're having a brain aneurysm and go post processor dot bloom blur 3. Then things start to get pretty blurry. I think, at least. Actually, surprisingly, not really. I might have to tear down the engine. Oh, I know what's going on. Okay, so these commands actually don't work until we do one thing. And that is we need to tell the post-processor to ignore the camera settings. Because we have a camera system in, and the camera system can override the post-processor settings that you set in the console. To stop that, you simply do post-processor.ignore camera true. That's going to ignore the camera settings, and then you can do post-processor bloom blur, and then we'll do 3. Alright, so that works. As you can see, all of the bright colors there. I actually had to take my glasses off because my glasses are kind of dirty, and I couldn't tell if it was being blurred properly or my glasses were smudging it, but I can tell that it is, in fact, the blur. So the text is now being blurred. That's great. Now we're on to saturation, which is another thing that we can set with post-processor.bloom saturation. And this is a fun one because you can really screw with the game's text when you mess with this. I'm going to set this to 1.6. By default, it's 1.3. And that's going to brighten up the colors a lot, or all the colors that get bloomed. Now, colors that are below a certain threshold don't get bloomed. So you can see that the white cursor here is being smudged out because it's bloomed. It's pure white, it hits the threshold. But the actual text of the console, and this is a really bad palette, the text doesn't really get bloomed all that much. But you can set that, you can change that with the post-processor.bloom threshold command. By default, this is 0.59, which is a percentage value. That's a percentage of how bright the color has to be in order for the bloom to kick in on it. If I set this to something really low, like 0.2, yeah, as you can see, a lot more things are being bloomed now. Yeah. I actually can't tell what's being bloomed and what's not being bloomed right now. Close the dev console and open it up again. Let's set it to something really low, like 0.02. And as you can see, things are way more bloomy. So yeah, as you can see, pretty much everything except for, like, pure black is being smudged and bloomed right now. So yeah. Now, another thing that you can set is the bloom intensity. Now, that's different from saturation. Saturation is just how much the engine is going to saturate each color toward its, like, full-on value. Intensity is going to set how bright things actually go. So post-processor.bloom intensity. And let's do something really mind-rapey, like 6. And as you can see, now everything's basically unreadable. This is like if you ate 10,000 pot brownies and tried to write some code. It's just not gonna work out. Everything's all bright and bloomy, and you can't read a damn thing. You might as well go to bed or go to a hospital at this point. Alright? That's what that command does. Thank God it doesn't affect the dev console, because I wouldn't be able to find my way back. So that's what the intensity does. Let's go back to something more sensible, like maybe, I don't know, 1.4? And as you can see, things are pretty bright and pretty blurry, but if you look closely, you can read it. Like, I can read some of these colors. This is what it would look like if you had a migraine aura and you were trying to read, like, a really bright terminal. You can do it, but you really don't want to. Or if you ate, like, 10 pot brownies. So on a scale... So, this is about... if I had to measure this in the amount of pot brownies you had to eat to get this kind of bloom effect, this would be 10. So let's go down to something even more sensible. Like, maybe, 1.2. And, you know, we're starting to get more to that point of return where we can start to read things. And of course, there's a threshold, so I could set this back to its default of postprocessor.bloom threshold 0.59. And now things are going to be heavily bright when they should be, or when they're above that threshold, which looks kind of strange, to be honest with you. Like, this is a little much on the bloom, especially when there are certain colors that aren't being bloomed. Like, this is a little much for a text-based game, but it's still kind of cool to see it. So yeah. Now, why am I showing you this? I'm showing you this because over the next little while, I'm going to be messing around with these shader values and dialing them in just right to have the game look really cool. And the console lets me do that now. You couldn't do that in previous versions of Thundershock. You could not do that. And the cool thing about this is if I ever screw up and don't know how to get myself back to, you know, normal, I can read things again, it's one command. Post-processor.ignore camera, false. The ECS is going to kick back in, and it's going to overwrite all of the changes I made, and things are going to go back to normal, to what the game wants. That's great. I could not do that before. So yeah. I have to add some shadowmask console commands for that. And in fact, before I end this off, I'm going to show you guys how to fix that whole bug there where we turned off the bloom and the shadow mask just completely raped the screen. It's a fairly easy fix, and I'm going to show you guys what went wrong and how to fix it. So we're going to go into postprocessor.cs here. And I want to make this a common thing where if I find a bug and it's easy to fix, I want to show you guys how I'm going to do it. So inside this function, or inside this class, we're going to come across a function that is called process, and it's going to take a render target and a rectangle in. And that process function is the key here. So we'll find that process function. The first thing that it deals with is the bloom. So it checks to see if bloom is enabled, and or like engine-wide bloom is enabled, and scene-wide bloom is enabled. If that's true, then it performs the bloom. Otherwise, it performs no effect. And the reason we do this is because we're setting up a post-processor effect chain. So what's going to happen is if we bloom, then it's going to render to an intermediate texture, and then that intermediate texture is going to be fed into the shadow mask effect. Which is mostly uncommented? Or mostly commented? No, this is the glitch effect. Ignore the glitch effect. But if bloom is disabled, we still need that intermediate render target to have something in it, so we render nothing but the source frame into that effect. And in fact, how fitting that I said we rendered nothing, because this is entirely commented out. This is a missing feature that I forgot to implement before the video, so I'm going to show you how to do it. So, delete all this. We have a render target that we're being given to this method. That's a key here. We want to bind it to the graphics card. We want to tell it that we want to render using this render target, or rather render a quad using this render target as a texture. And the way we do that in Thundershock is we do gpu.textures 0 equals, and then the render target. Now this is just like monogame. It's the same way you would do it in monogame with the graphics device. Bind the render target as a texture. That's great. And then the next thing that we want to do is we want to render this to the intermediate buffer, which is another render target. And this is the buffer that's going to be sent along to the next effect in that chain. So we need something to be in it. We need the source frame to be in it. So the way this works is the result of an effect will be rendered in that intermediate buffer. And then that intermediate buffer will be given to the next effect, which will render its effect back into the intermediate buffer. And then at the end of the day, that intermediate buffer is going to be rendered back to the screen. And that's going to be the finished post-process effect. So, we need to take this source render target here that we've been given and render it into the intermediate buffer. So, how we do that? Well, we realize that the intermediate buffer is another render target. So, set render target, intermediate. Render to the intermediate buffer. Cool. Awesome. Next, we need to tell Thundershock what shader we'd like to use, because it could be screwed up right now. We could be rendering with the shadowmask shader right now, and we don't want to do that. So we need to explicitly tell it, okay, this shader, apply this shader when we do the next render. And we do that by, well, the shader we want to use is the basic effect. So, basic effect. Now, an effect in Thundershock, unlike monogame, is made up of multiple programs. Well, usually there's going to be only one, but in the case of the post-processor, there's multiple. So we need to get the first program. And then the program is what we want to actually use on the graphics card. So we call apply on that program to apply it to the graphics card. This is going to tell the graphics card to use this program when it renders the next item. Use the basic effect shader program for this next render. We don't want any special effects here. Just the source frame. Alright. And the next thing that we need to do is actually prepare the render, which is one function call, gpu.prepareRender. Now you can send things along like the blend mode, but alpha blend is fine. It's all we need. And then we render the quad. And this quad, well, a quad is a quadrilateral. That's what that means. It's a four-sided shape. And in graphics programming, you generally deal with triangles. So, well, think about it. Triangles are three-sided. If you put two triangles together side by side, you get a four-sided shape. So, we want two triangles here. So, to render, what we're rendering is a rectangle here. We're rendering a single rectangle of the screen that's a big texture, basically. That's what a quad is. And that's already been set up by the post-processor. That's what this does right here. These two lines of code. This tells the graphics card what we want to render. Now we're telling it that we want to render it. So what we do is, to render that quad, we need to realize that A, a quad is made up of two triangles, and B, it's made up of triangles. So, render the quad. I'm going to show you how simple this is. gpu.drawPrimitives, we need to tell it what type of primitives we're drawing, so in this case, triangles. So, primitive type dot triangles. Or triangle list, sorry, because it is a list of triangles. It's 2 triangles. And we need to tell it what vertice to start at. 0. It's always going to be 0 unless you're dealing with batch rendering. Always. Always, always, always 0. And then we need to tell it how many primitives we want. Now, a quad is 2 triangles, so we want 2 primitives. We're done. We're done. As simple as that. Now we just clean up. So, we end the render. We unbind the render target. And we unbind the texture. Done! Bug fixed. And we're back. So now, what should happen is I should be able to pop into the dev console here and do, first of all, post-processor .ignore camera true. And then I should be able to do post-processor .bloom false. And as you can see, the text is still readable. It is still being shadow masked by the CRT shadow mask effect, but it's not doing that weird thing with the colors anymore. And that's great. And, of course, because we've also fixed that no effect bug, we can turn off the shadow mask itself and look at the game in its plain old, boring, default, no shading whatsoever look and feel, and it's really not that great looking, to be honest with you. I definitely prefer it with the bloom and everything, but that's cool. So we basically did the console command version of unticking this text box, or this checkbox, unticking this checkbox, and clicking close. We did that through the console. And now I just need to make it so that we can do it through the actual settings window. But anyway, that'll do it for this video. A bit of a long one. I want to make up for the lack of videos I've been making, so hope you enjoy these long ones. And as always, I've been Michael. As always, I hope you learned something, and I hope to see you on the Discord server sometime too. We've been getting more members recently, and I'd love to see you guys there if you're not there already. You get to see a lot more of this Thundershock development stuff, and with that said, I've been Michael, and I will see you guys in the next video. Thanks for watching.